Hi everyone, today we're going to be talking about arrays and loops, which are two extremely important parts of all programming in all languages. So it's really important to understand these ideas. So when you initialize an array, if you remember back to our lesson about variables and data types, it's basically the same thing. So your array is a variable and you have to initialize it with a data type. And that data type is going to be telling Java what sort of values are inside the array. And an array is just a list of objects. So it could be a list of integers, strings, doubles, etc. So let's make an array of integers. So we're going to do int and then put two brackets after to tell Java that it's an array, and then the name of the array, and equals, and then we're going to make our array. So one way to initialize an array is to use curly brackets and just type in the array. So I can say 1, 4, 5, 7, 9. So now I've initialized an array, which is a list of those integers that I just typed in. And if I add a double to the array, it will not work. If I change one of the numbers to a double or a string, it won't work because the array has to be integers. And Java also preserves the order of the numbers in the array. You can access specific elements depending on where they're indexed in the array. In the same way, I can do string R1 equals and make an array of strings, which will be an ordered list. So hello world. All right, so that is one way to initialize arrays, but sometimes at the beginning of a program, you won't know what the array you want is yet, and you just need to initialize it and add values to it later. So in Java, you have to know the size of the array when you initialize it. Java just makes the array with that size and fills it with zeros. If I do int r2 equals, and then in order to just initialize it as an array of zeros of the correct size without knowing the actual values yet, I would say new int and then put the size inside. So if I want the size to be 7, that means there are 7 entries in the array. I can put a 7. And now Java has stored a memory location for R2 that is a list of 7 zeros. And in Java, you cannot change the size of the array once you've set the array unless you completely reset it. For example, with our array R1 of strings, if we tried to add an entry to R1, we would not be able to because the size right now is 2. So the size we told Java is 2, and we cannot make it greater than that. But we can reset it to a new array of a different size. However, that would erase all the memory we already had stored in the array. Okay, so now we're going to talk about array indexing, which basically means accessing an element at a specific point in the array. What I mean by point is the position the element holds in the array, and those are called indices, or an index. So in Java and pretty much all computer science, you begin with 0. So if we take our first array, 1 would have index 0, 4 would have index 1, 5 would have index 2, and so on until 9 has index 4. And so you see that the indices of an array go from 0 to the length of the array, which we can get by saying r.length minus 1. Those will be the valid indices of an array, and if you try to access an element at an index that is outside of those bounds, then you will get an error in the compiler. We can try to access an entry using an index. So say I want to print hello world again. So I can say system R1 at 0 to get hello, and then I'll add a space and alright, and I have to delete this because I reset R. And if we go and run this, we get hello world because the first term here is calling hello, and this one is calling world. So that's how you would index elements out of an array. We can also look at the length of an array, which I already sort of talked about, but we can see, well, how long is R1? We can do R1.length. And it's 2. So hello and world make 2. And remember, the indices go from 0 to the length minus 1, which would mean 0 to 1, which is correct, as we saw in this print statement. Another thing we can do is change the element at a certain index of the array. So if I take our first integer array, for example, I can say r at 3, which is currently 7. I can change it to 4. And then if I print that element, then we'll see that it has changed to 4. And I can also say R3 plus equals 1, which means it's going to do itself plus 1, which is also the same as saying plus plus. These mean the same thing. I'll write it here. Plus equals 1 plus plus. Increment by 1. So if I do R3 plus plus, then I have it used to be 4 and now it's 5. So let's comment out these print statements and try to do something that maybe you've thought of. Why can't we do that? Well, what if we try to just print the array? Will it format it nicely and print all the entries, or will it do something weird? Let's see. So it prints this weird string of letters and symbols that we can't really understand, and that's because it's sort of printing the object memory location for an array, and we'll see how to combat this later once we learn loops. So we're going to move on to loops now. Our first one is going to be the for loop. And here's the basic idea about loops. So when you make a loop, you give it a condition and a body. And the body has the statements that you want the loop to execute. And as long as the condition is met, the loop continues to execute those statements. But as soon as the condition is no longer satisfied, the loop exits and the program continues. So let's do an example. So for a for loop, you're going to start with the word for, and then you have parentheses, and inside you're going to need, let me comment this out and show. So you're going to need an initialization step, and then the condition that I mentioned, and then an increment or a decrement. And the increment or the decrement should be in the form of plus plus, or for a decrement, minus minus. And then you're going to do brackets and write the statements here. So let's try to write a for loop that prints every element in our array. So we're going to do for, we need to initialize first. So we're going to say for an integer I, where it first equals 0. And then remember that the array indices run from 0 to the length minus 1. So we can say as long as I is less than the length, we'll keep going. And then we're going to increment I each time. So I is going to go 0, 1, 2, all the way up until when it's less than the length. And when it equals the length, it's going to exit the loop, so we will not get an index out of bounds error. So now we can write the body statements. We want it to print that entry in the array. So we're going to say system.out.print, and we're going to print the array at that index. And let's see what happens. So we got 1, 4, 5, 5, 9, and remember that's because for the 7 we changed it to a 5 and everything else stayed the same. So it did print every element. We can even print them all on the same line and with a space to make it look more like a list. So now it's printed more like a list. I forgot to put a print line at the very end, so my terminal printed right onto that line, but I can do that here, and then it would work perfectly. So that is the basic idea of a for loop. Make sure you have all 3 conditions, or else it will not have all the adequate parts to loop through your statements. And notice that if I say I did it's less than or equal to the length, then when I is equal to the length, it's going to try to go in this body and execute the statements. So it'll do R at the length, which is not valid. So we'll see what happens there. So it says exception in thread, index out of bounds. So make sure your bounds are really accurate and you won't get an error. So now we're going to move on to a for each loop. A lot of times you can't do the same things you can do with the for loop using a for each loop, but then a lot of other times it's much simpler to use a for each loop. So let's say for each loop. Let me go ahead and comment all of this out. All right, so let's try to write the exact same program we just did, but using a for each loop. So here's how a for each loop works. You're going to have for, and then parentheses, and you're going to do initialization, and then in some sort of list or array, and then bracket statements. So here's what that means. For a for each loop, you don't actually write for each, you still write for. In the parentheses, you're saying for int I in R, and you're going to tell it to print I. So notice that I now is not the index, because before we had to print the array at I. Now I is the actual entry in the array, and we're just printing I. So this is essentially saying for each element, which happens to be an integer, in the array, print that element. So let's try that. And it worked again. It did the same thing as the first time because I used print line instead of print. So you can do the same thing with R1, which is strings, by just saying string I in R1. And it would do the exact same thing. You can try that. Hello world. So for something like this, where you're just iterating through the elements of an array or a list, it's much simpler to use a for each loop, but sometimes if you need to use an increment or a decrement, you can't use a for each loop, you have to use a for loop. So it's really important to get familiar with both of these. So let's try to write a program using a for loop. That's a little bit more complicated. Let's try to write a program that takes in an integer, a positive integer, and returns that integer factorial. So let's call it n factorial. So we're going to use a for loop to find n factorial given n. So first we need to get n from the user. So let's say enter a positive integer. Okay. And then remember how we use scanner. I already imported scanner and established the scanner object. So I'm going to say int n equals in dot next int, because we need an integer in order to do factorial. Okay, so now let's think about what we need to do using n. So we need to take a number, let's call it fact, which is going to end up being the answer, and we're going to set it to 1, because that's the multiplicative identity. If we set it to 0, then it would make everything 0 if we multiplied it by something. And we need to take our variable fact and multiply it by every integer beginning from 1 and ending at n. So if we say for int I equals 1, I less than or equal to n, and I goes up, so I plus plus, we say fact times equals I. So times equals is the same as plus equals. It's just saying, this is saying fact equals fact times I. And then we can go and print fact and see if it works. So enter a positive integer. Let's do 4 factorial. It should be 24, and we do get 24, so it does work. We can try it again. Let's do a bigger one. Yes, that is 10 factorial. So the loop does work. I'm going to show you a trace of this loop, which is basically when you use a sheet of paper and a pencil and trace through exactly what the computer is doing. And this is essential for debugging and really understanding loops. So I'm going to show you a trace. Okay, so let's start the trace. We have 2 variables that we need to keep track of, I and fact. We can make a sort of chart here. Okay, so fact begins at 1, that's before the loop even starts. Then we go into the loop and we have I equals 1, and fact equals itself times I. So fact equals 1 times 1, which equals 1. Okay, and then I goes up 1, so it's 2, and 2 is less than or equal to 4. So I becomes 2, and it goes back into the loop and does fact equals itself, which is 1, times I, which is 2. So now it's 2. Okay, and now we go I pluses 1 again, which makes I 3, and I is still indeed less than 4. So we go back into the loop with I equals 3, and fact becomes itself times I, which is 6. And then again, I goes up to make I 4, and we look at the condition, and I is still less than or equal to 4. 4 is equal to 4. And so we go back into the loop with I equals 4. Fact equals itself times I, which is 24. And then we, one more time, increment I, and we get I equals 4 plus 1, which is 5. And then we go to the condition. 5 is not less than or equal to 4, so we continue for the rest of the program outside of the loop. And fact is equal in the end to 24, which is our final answer, and that's what we were printing in the program. And now we're going to do one more example with a for loop. I'm going to use what is called a block comment to just get all of this without commenting out each line. All right, so we're going to do one more example with the for loop. And that's going to be printing our original array, but skipping doing every other entry of the array. So we're going to begin with our for, and then initialize the index, so I equals 0, and then we're going to do the same bound as before. I is less than the length, but this time for the increment we're going to do I plus equals 2. So that means I is going up by 2 every time instead of 1. And then we're going to print R at that index, and it'll print every other element in the array. So let's try that. So it does 1, 5, and 9, which is every other element, which is correct. And then if we want to print every other element beginning from 4, we can just do, starting at the index of 4, which is 1, we could just do this. Because remember, we made 7, 5. And the reason I wanted to show you this is because this is something that's much harder to do with a for each loop. Even though for each loops are much simpler when they can be used, usually you still have to use the regular for loop. Okay, so now let's move on to the last type of loop, which is a while loop. While loop. So for a while loop, you have while and then any Boolean condition and then the statements. So a Boolean condition is just any condition that returns a Boolean. This is the same as in a for loop, but the difference with a while loop is that you can have multiple conditions. You can say all of these conditions have to be true, while in a for loop it's much easier to have one condition, but in a while loop it's very intuitive to have multiple. So let's try to write a program that finds the first non-zero element in a list or an array. So let's make a new array so that we can test this, since none of our arrays really have zeros in them. So we can say int array, what am I on now, 3? Array 3 equals new int, and we can make it size 10. And now remember, Java automatically fills in R3 with zeros. And so if we want to find the first non-zero element, we can make a couple elements non-zero and see if it finds the first one. So we can say R3 at 5 equals 35, R3 at 8 equals 2, and we can do one more at 9 equals 9. So we want to find the first non-zero element in this list, and we know it's 5. So let's see if we can write a program that outputs 5. Okay, so we need to start with a Boolean, a variable that tells us whether we're done or not. And so let's call it done. And we're going to set it to false. And then we need an integer increment, since in the while loop you don't initialize. So we need to initialize it beforehand. And we're going to say it starts at 0. And then we can do our while loop. So here what I just initialized, I, is doing exactly the same thing as what it was doing in the for loop. It's just going to sweep through the indices of R3. So we can say while I is less than r.length. Remember, that's the same condition we had in the for loop. And then we can say and, which is an operator that you learned in the previous lesson, and done is false. We want done to be false in order to go into the loop. If done is true, then we want it to exit the loop. So we're going to say not done, which you can do with an exclamation point. Oh, I realize I'm using R and not R3. Okay. Now you want to look at that index I of R3. So we're going to say R3 of I. If it's not equal to 0, then since we're going from left to right in the array, the first non-zero element that we see through our loop is going to be the very first one because it has the lowest index, so that's going to be the one we want. So we have the first non-zero element is at index, and then put the index. So we've found the element we want, and we don't want the loop to continue. So now we're going to set done equal to true, because otherwise the loop will continue and it'll keep printing for every single non-zero element. The first non-zero element is at this index, and we don't want that. So we set done to true, and the next time when it comes around to do the loop, it'll see not done is false, so then this whole thing will be false, and it will exit the loop. And then a key step that you cannot forget in while loops is you need to increment inside the loop, since you're not incrementing in the parentheses like you were in the for loop. So you cannot forget to increment, otherwise it will become an infinite loop and it will never exit and your program will never finish. So don't forget to increment. Okay, and let's try this. So it says the first non-zero element is at index 5, which is correct. Now we can try, what if we set at 5 back to 0, and it will be at index 8 now because at 8 is 2 and 5 is 0. And then what if we just had none of these at all and the entire array is zeros, so there are no non-zero elements? Then let's see what it'll do. It'll just do nothing because it never enters this if statement. It never enters this if statement, and so it never prints anything, and that just means that there are no non-zero elements in the array. The array is completely zeros, and that also shows why we needed this condition. We already saw why we needed this condition, but now we see why we need the I condition, because if we didn't have that, if it was just done, we can try that actually. If we did not have the I is less than length condition, then here we would have an error my program is just not ending because it never exits the loop. All right, so I'm going to terminate that. I'll write it here. Okay, so this covers arrays and loops. We did the 3 main types of loops. And I'll leave you again with a summary of the key points in syntax in this lesson. Make sure you do the assignment. It should help you gain a better understanding of everything we went over, and remember to always keep practicing and testing and experimenting with all the different things that Java can do, especially using loops and arrays.